So we are basically done with the taxes portion. I did want to do one example of the property tax stuff. I know we mentioned that last time. So I'll do one example of property tax stuff today, and then we'll move on and get into interest calculations. All right. So if you recall, you're dealing with property tax, and I kind of quickly went through this. Property tax is based off of what's called a millage rate. Oftentimes, when you go into the voting booth, you have to vote on a certain millage for, school improvements or new park or whatever it happens to be. Well, this is what that's about. All right. A millage rate is a tax rate, how much you pay per $1,000 worth of taxable value. So all you have to do is take, how much you owe, which is called the tax levy. We can just call it tax. It's going to be the taxable value of the property divided by 1,000 and then multiplied times the millage rate. Okay, again, a very straightforward calculation. So let's do an example which says assume the taxable value on a home is $145,000. By the way, again, taxable value doesn't mean I can buy that home for $145,000. Maybe I can buy that home for $290,000. Right? Sometimes the taxable value is much, much less than the actual home is worth. Sometimes the taxable value is pretty close to what the home's worth. Just kind of depends on how it's being calculated. So we're going to assume taxable value is $145,000. There's a total millage rate of 30.85. What would we pay in property taxes? So all we do is we say our tax is the taxable value, which is $145,000. We're going to divide that number by 1,000. And then we're going to multiply times the millage rate, which it said was 30.85. Right, 30.85 was the millage rate. Now I'm going to do this in 2 steps. Normally I just type this in my calculator, all right? But I want to do it in 2 steps. Just so we understand what's going on. 145,000 divided by 1,000, you take 145, and then you multiply by that 30.85 millage rate. So basically, each $1,000 worth of taxable value is costing you $30.85. Worth of property tax. Is that okay? Does that make sense? And if you calculate that out, $30.85 per $1,000. That's a tax rate about 3% of your taxable value. Okay, so oftentimes people will talk about the millage rate. If you talk about a percentage, you have to move the decimal over one spot. It's kind of a weird system. We follow that. So if you're wanting to use a percentage, you'd move it over one spot. But for whatever reason, historically, they always use this millage rate scenario. It's cost per $1,000. So we take the 145,000 times it by 30.85. Oh, not that's 145,000. Sorry, 145 times it by 30.85, and the tax on that property would have been $4,473.25. Like always, we round to 2 decimal places. So that's the concept of property taxes. That work? It's a pretty easy calculation to do once you know it. And it's very similar to the percentage calculations we've been doing, except for now we have this millage rate instead of that's how much money you pay per $1,000 worth of property taxes. So you're paying $30 for every $1,000 worth of taxable value. Okay. Yeah, weird kind of concept. So that's all I wanted to do. I wanted to do at least one property tax value. Calculation. I'll skip the other one. If you want to do that other one on your own, that's fine. Now you might ask, well, how could I lower my property taxes? Notice that in this equation, there's only 2 variables. You either lower how much the taxable value is, that's lower how much the house is assessed at, or you change the millage rate. And changing the millage rate for the vast majority of people means you have to move to a different location. Okay. So for me, I live in the city of Mount Pleasant. It has a higher millage rate than if I would have lived outside the city. Okay. So if I wanted to, I could lower my property tax burden by moving outside of the city. Does that make sense? Now, obviously, that has some trade-offs too. If you move far out of the city, then you have to drive. It takes a lot longer to drive and all that kind of good stuff. So it's very convenient to be in the city of Mount Pleasant. But yeah, if you want to lower your property taxes, really only 2 options: change the millage rate, change the taxable value. Most people, the most effective way to change the millage rate is move different locations. Obviously, you can get people you want elected, and then they could change the millage rate, through that process too. But it takes a longer time. Harder to do. All right, everybody okay with taxes? Property taxes, all that good stuff. All right, so let's start dealing with interest. Interest is the other half of this unit. So we did taxes. That's our first chapter. The second chapter is on interest. So what is interest? Well, you can look at it one of two ways. It can be money that is charged for me borrowing money. So I take out money and then I have to pay it back plus a little bit extra. That little bit extra is called the interest. Or if I am the one that's investing, I put my money into a stock or an account, and I'm the one making the money, that profit that I make on my invested capital, invested money, is also interest, right? So it's money you make on top of money, or money somebody else makes on top of money. Right? The vast majority of people are going to have to deal with interest. In fact, everybody has to deal with interest, basically. If you ever want to take out a loan for anything, then it's going to involve interest. If you ever want to save for retirement, it's going to involve interest. All right. Interest is how and why banks make loans. It's also how the stock market works. All these financial markets work on interest of some type. Money made on investments. Right. So it is a big deal. Now we're going to make some assumptions as we go through this section, as we go through this chapter. These assumptions aren't always going to apply to everyday situations, but we're still going to make them just to make our lives and our calculations easier. All right. One of the assumptions is that the interest is going to be accumulated at a certain period of time over and over and over. So every year interest will accrue, or every month interest will accrue, or every day interest will accrue. And we'll keep that same period the same throughout the entire problem. Okay. Now, one problem it may say every year, another problem it may say every month, another problem it may say 4 times a year. But in each problem, we'll set a period where interest is accrued. And then secondly, we are going to have a fixed interest rate. This is not always the case when you deal with stock markets. Sometimes stock markets can go up, down, and change. Sometimes loans can change the interest rate. But for the sake of our calculations, we're always going to assume a fixed interest rate. Okay. Now, let me go through an example and show you how this kind of works. We're going to start with $4,000. And we're going to gain 4% every year. We'll do that for 3 years. And then we're gonna ask how much are we gonna have after 3 years is gone by. So we gain 4% each and every year. So here's what's gonna happen. In year 1, we're gonna start with $4,000. My ending amount, well, it's just gonna be like sales tax calculation in that I'm gonna take how much I start with, and then I'm gonna gain, it says I'm gaining 4% on top of this. So just like we tacked on 6% sales tax, this time it's a very different scenario, but it's the same calculation. I'm gonna tack on 4%. And so the ending amount of year 1 is gonna be given to me by taking that 4,000 and multiplying it times 1.04, right? Which is 104% of the original. Everybody get that? Why it has to be 1.04? So at the end of year 1, I end up with $4,160 end of year 1. So in some ways, we gained 160. Now the key factor in this interest calculation is that in year 2, we are not going to gain 160 again. Because the interest that I accrue isn't applied to the 4,000. It's actually on year 2. In year 2, I'm going to start out with 4,160. Instead of starting out with 4,000. Does that make sense? And so I'm going to accrue interest on the entire 4,160, which is just multiplying by 1.04 again. So at the end of year 2, I get $4,326.40. And then I just said, let's do this for 3 years. So we'll do year 3. At the start of year 3, I'm starting with $4,326.40. And in order to accrue the interest, I'm going to take that amount. And again, I'm going to multiply it times 1.04. So at the end of year 3, I end up with $4,499, and I'll round that to 2 decimal places, 46 cents. Does that make sense? Notice what I did. I multiplied times 1.04. And then I multiplied again times 1.04. And I multiplied again times 1.04. If I wanted to have gone from the start of year 1 to the end of year 3, what I could have done is taken 4,000 times 1.04 times another 1.04 times another 1.04. Probably easier to write that with exponents. 4,000 times 1.04 to the 3rd power. You guys know how to type in on your calculator to the 3rd power? All right. If you don't, let me show you real quick. I gotta change my camera here. So I'll do both both calculator types. Okay, you already saw me calculate that. But if I do 4,000, what I can do is hit the parentheses. Again, above the 8 and the 9. Parentheses 1.04 in my parentheses. And then on this calculator, the exponent key is this one. And on this calculator, it kind of indents it as an exponent. So there you go. And sure enough, we get 4499.46. On the other calculator, the TI-30, it's the exact same thing. We go 4,000 above the 8, parentheses 1.04 in my parentheses. And then it's still the caret, but the caret is over catty corners of 7. So you get that caret 3. And because the calculator will obey orders of operations, when you hit enter, it'll give you the right number. Okay. So that's how the interest calculations, we're going to use that exponent key quite a lot. In these calculations, we use the exponent key quite a lot. Does that work? All right. Now, whenever we do this yearly, that same technique is going to happen. I can take my initial starting amount. Now, my initial starting amount has a special word that's associated with it. My initial starting amount is called principal. All right. And then you just take 1 plus your rate. That comes from 104% to some exponent. Obviously, if we did this for 3 years, our exponent would be 3. If we did this for 10 years, our exponent would have to be 10. If we did this for 15 years, our exponent would have to be 15. So whenever we're dealing with yearly, we're going to do that. Now, we're not always going to deal with yearly calculations, though. All right. And this is going to bring us to the general interest formula. All right. So that one you saw on the previous slides, that just applied to the yearly interest when it was compounded yearly. But now we're going to go to the general interest formula. Okay. So since we can compound every year or every quarter or every month or every week or every day, we have to account for that. And basically, if I said we're going to compound every year 4%, that's fine. If I said we had to compound 4%, but I have to do it quarterly, what's gonna happen is I'm gonna take that 4% and I'm gonna divide it by 4. That 4% is a published rate that looks like a yearly rate. So what we're gonna do is we're gonna divide it. If I did quarterly, I'd divide it by 4. If I did monthly, I'm gonna divide it by 12. Does that make sense? So let's say a bank will give me a loan for 3% interest. When the bank says 3% interest, they're publishing that rate as a, it looks like we're charging you 3% at each stage, 3% per year at each stage. So when we talk about a published rate of 3%, if we are compounded yearly, I'm going to use 0.03 or 0.03 divided by 1. If the interest is compounded quarterly, so here's my rate. Oops. Compounding per year. So yearly means I'm compounding 1 time per year. So my rate just stays at 0.03. If I do this quarterly, we're compounding 4 times per year. So my rate is going to change to 0.03 divided by 4. If we're compounding monthly, compounding monthly means 12 times per year. So I take my 0.03 and divide it by 12. If we're compounding weekly, how many weeks are in a year right now? 52, roughly 52. So we'll go 52.03 over 52. Okay. Does this make sense? And then if we compound it daily, like 365 days in a year, we won't use leap year calculations. Let's use 365, 0.03 over 365. Okay. And so what's really going on, I kind of like to think of this on a timeline. If I take a 1-year timeline from start to finish, when we compound yearly, we go from start to finish at 0.03. And I'll just do let's do quarterly. What's going to happen is you're gonna use 0.03 over 4 once, twice, 3 times, and then 4 times. Does that make sense? You draw it like that. So you're gonna do it 4 times a year, but in order to get that same percentage rate, you have to take the 0.03 and divide it by 4. So it's not 3% 4 times a year, it's 0.03 divided by 4, 4 times a year. So that's the concept of the rates. And the bank is always going to publish the interest rate as 3%, and you have to, divide by the appropriate amount. Okay. Now, think about this as well. I've done everything for a year. How many periods, compounding periods per year? What if we said, well, the bank is going to give me the loan for 10 years. Or we're going to invest for 10 years. If the bank gives me a loan for 10 years, periods per 10 years. Well, how many jumps am I going to have? If it's once per year, if it's compounding yearly, then the number of periods, the number of times I have to do my multiplication or my exponent is going to be 10. If it's compounding quarterly, because there are 4 jumps per year, over the course of 10 years, that's going to account for 40 jumps. That makes sense? Over the course of 10 years, if we're doing this monthly, I have to take 12 times my 10 to give me 120. There's going to be 120 jumps if we do it monthly. Does that make sense? When I say jumps, I mean compounding periods. I did jumps because I had that drawing up there earlier. 520 compounding periods if we're doing weekly. And 3,650 compounding periods if we're doing this over the course of 10 years. And you just say, well, if we're doing it 4 times a year, multiply by 10 years, that's a total of 40 compounding periods. That all makes sense? And this is going to be my exponent. If I invest quarterly at 3%, this now is going to be my new rate. And if I invest for 10 years, we're going to end up multiplying 40 times, which obviously multiplication by 40 times by hand would take us forever. But since we have the calculator and exponents, that doesn't take us very long at all. Okay. All right. Oops. So here is the interest formula, right? This is the general formula for interest that you should know, or at least have written down somewhere in big bold letters as you're doing your homework or as you're doing the test. It is A equals P times 1 plus R over M to the MT. The M stands for how many times per year is our interest compounding. Now, the other letters there, the A stands for the amount at the end of whatever period of time we're looking at. P stands for the initial amount. So earlier we started with $4,000 and we ended up with $44.9946. So the A would have been the $44.9946 and the P would have started with the 4,000. Again, that P is called the principal. Some people also call it a present value, how much you have at the present. I like the word principal a little bit better, but we will come back and talk about present value and future value later, okay? And by present value, we just mean the starting amount. By future, we mean the ending amount. Does that make sense? So you start by putting in the principal, you get out the A at the end. You take 1 plus, again, this R is going to be the published rate, published interest rate, divided by how many times are we compounding per year. And then our exponent is going to be the number of times we compound per year times the number of years. So that T stands for the number of years we're compounding. And this formula does a lot of work in this chapter, okay? In fact, it is the main formula that we're going to use throughout this chapter. You know how to deal with this formula really well? You'll do really well in this chapter. All right. Oh, I was just, if you ever think, right, P principal is the starting amount, A, that's the final amount, okay? You can compare this to like a race, and there's a lot of different comparisons you can make. Like the M might be how many jumps we do or how many steps we're taking, right? Per however long the you know, per 100 meters or whatever. T, how long it takes you. R, how fast are you taking those steps? All right, those types of things. But again, P is the starting, A is the final. That's the big thing. So let's do an example of how this is going to work. Let's say we put in $1,500 into a bank account. That gains 4% annually. I should say 4% compounded annually. How much will you have or how much will be in the bank account after 14 years. Is that right? So this is general interest. We're just plugging in a certain, we're putting it in, we're not touching it. Okay, we're putting in one lump sum of $1,500 and then we're not touching it for another 14 years. Everybody get that concept? I like rewriting, especially in my notes, rewriting this formula. Obviously, if I was doing a test or a homework, maybe I wouldn't. But remember, the whole purpose of taking notes is so you can go back and reference how you did it. So I like in my notes to have that formula written. How much after 14 years? Well, I'm looking for the A. So A is my variable. We're putting in 1,500. That's my principal. In parentheses, I gotta do 1 plus R. Now R has to be the decimal version of this rate, so it's 0.04. M is 1. And we're gonna multiply, well, we'll divide by the 1 here. And then we're going to multiply the 14 by the 1 in my exponent. All right. Now, when you're typing this in your calculator, be careful about this exponent. Okay. What I like to do is I like to do this multiplication and just say, well, 1 times 14 is 14. I do that in my head, and then I plug it into my calculator like that. Here's why. So if we take 1,500, parentheses, 1 plus 0.04 divide by 1 in my parentheses. If I do a caret and then do 1 times 14, what's going to happen is I'm going to get the wrong answer. Okay? Because if I type it into my calculator that way, that's like telling it to do an exponent of 1. And then after you do the exponent of 1, multiply your answer times 14. Everybody see that? So if you want to write 1 times 14 in the exponent, you're going to have to write in parentheses 1 times 14 in parentheses. I think that takes longer than me just calculating out 1 times 14 is 14. So I just tend to, as I'm typing into my calculator, I do caret 14. Oops, can't see that, can you? Caret 14, and then just hit enter. So what I end up with is that the amount in this account after 14 years would be $2,597.51. And that's what it asked you for. By the way, if you had a different calculator, this one, you treat it just the same. This one, again, I'd probably just multiply 1 times 14, but because this indents to 14, the calculator will know, since you typed in 1 times 14, that that entirety thing is in the parentheses. Does that make sense? So on this type of calculator, when it does the indentation for you, it's not a big deal. But on the TI-30, it is a big deal. So you'll see me often when I type things into my calculator, I will have already multiplied those exponents so that it works out nicely. Is that right? All right. All right, I want you to try this one. Now we're compounding quarterly. And we're putting in a different amount. We're compounding quarterly. The gain is slightly different. It's 3.5% rather than 4%. How much will you have after 8 years? Go ahead and try to do this one on your own. Good. All right. So let's take a look at this one. So, same formula. We're looking for how much we want in 8 years. Principal in this case is $12,650. 1 plus. Be careful when you write this rate. It is 0.035. Okay. Oftentimes people won't move the decimal correctly 2 spaces over. So 0.035. Since this is quarterly, quarterly is 4 times a year, which means my exponent is going to be 4 times 8. I type that into my calculator. Again, oftentimes when I type it into the calculator, I'll do the 4 times 8 first and get a 32. And so I'll just type in 32 in my exponent. All right. And that's what I did. So the amount that we're going to have, or this person will have in 8 years, is $16,717.22. Again, all of these numerical money valuations, we round to 2 decimal places. So 16,717.22. So notice over that 8 years, this person started with 12,000 and ended up with 16. That was a gain of slightly over $4,000, right? So the gain was slightly over 4,000, which that's a big deal. Big deal. As I often say, better than a poke in the eye, right? It's better than getting nothing. Now, all of the same principles work the same no matter what scenario we're in. So I want you to try this one on your own as well. Rich person put $72,475 into a stock. That stock getting 7.25% interest compounded monthly. How much would that rich person have if they left the money in the stock for 20 years? All right, so as I was walking around, most people are doing really well on this, so I'm just gonna go through it fairly quickly. We're going to have a principal now of $72,475. One plus a rate of 0.0725. Be careful on that rate. Divided by an M of 12. And then my exponent is going to be 12 times 20. Okay. By the way, 12 times 20 is 240. So when I type that into my calculator, I tend to just write 240. I'm gonna write that, maybe I'll write that over here, 240. When I do type this into my calculator, I end up seeing that after 20 years, this $72,475 gets me $307,624 and about 24 cents when I round to 2 decimal places. Notice compared to the last problem, we've gained a lot more money, right? In the last problem, we gained about 4,000. Here, we're gaining like 230,000. And that's because of a few different things. One, we put in a lot more to start out with compared to the last problem. Another was that our interest rate was higher than the last problem. Another was that we waited longer. 20 years instead of 8 years compared to the last problem. And then we're compounding monthly rather than quarterly too. So we're actually compounding a little bit faster too. Which helps a little bit too. And that all combined made a huge difference in how much I have at the end of the time period. Now, what we're going to do in the next section is we're going to break down what parts made the most difference. So we compounded more often, we put in more money, we waited longer, and we had the highest interest rate, going from example 3 to example 4, right? In section 1.1. So we're going to kind of piecewise manipulate each of those components and see how much of a difference does it make to change my principal. How much of a difference does it make to change my rate? How much of a difference does it make to change how many times you're compounding per year? How much of a difference does it make to keep the money in longer, for a longer period of time? Okay. So we're going to do some comparison on each of those individual. On adjusting the principal, the P, adjusting the rate, the R, adjusting the compounding time, the M, and adjusting the time, the T, from our general formula. Okay. Now, I don't think I'm going to do all 3 of these. I think I'm just going to do the first 2. Okay, does that work? Let's do compounding monthly and then compounding quarterly. But we're gonna start with the same principle in both cases. And we're gonna have the same interest rate in both cases. We're gonna have the same time in both cases. So we're gonna take the principal of 2,000. The rate, 6% for 15 years. And in one instance, let's compound monthly. And in the other example, we'll compound quarterly. And see how much of the difference we have. So we'll do that one over there. We'll do this one over here. Principal is 2,000. Rate 6%. 15 years. All that's the same. Now we're going to compound quarterly. Let's do both cases and compare and contrast. So if I compound monthly, I take my 2,000, 1 plus 0.06 divided by 12. The exponent is going to be 12 times 15. That's going to be 180 when I plug it into my calculator. All right, 12 times 15 is 180. So I take 2,000, 1 plus 0.06 over 12 to the 180 exponent. I got an amount which is 4908.19. By the way, let's just note this before we move on. The money gain or the interest gained by that I mean the money we gained from our starting to our ending amount. That's how much total interest was gained money-wise from our starting to our ending amount. Just take 4908.19, subtract the 2,000. Is $2,908 and 19 cents. Everybody get where I'm getting that number? Started with 2,000, ended here. So if you take out what you put, the gain is $2,908.19. Let's do that for compounding quarterly as well. If we do the compounding quarterly, it'll be 4 times 15 in the exponent, and then we'll have to do 0.06 divided by 4. By the way, 4 times 15 is 60. So you can put 60 in, type that in. The amount gained was the amount you have is 4886.44. And so the interest gained in this case would have been 2886.44. Is that right? So which scenario gained more interest? Well, the scenario where we compounded more often, right? 12 times a year is more often than 4 times a year. So we're going to gain slightly more interest when we, in total, if we compound 10 times rather than 4. Everybody right with that? Now, is it going to be a huge difference? No, it's not going to be a huge difference. So we went from compounding 4, we tripled that to compounding 12 times. But our interest, we only got about a, what's that, $20 difference, $22 difference there. So compounding more often will yield more interest, but it's not a huge change. Everybody okay with that? And that's what I want you to take away with this part. Compounding more often will change the final amount of interest gained, but not by a huge amount. So let's do this. Let's change how much we're starting at. So what I'm going to do is I'm going to start with $2,000 again at a 6% interest rate for 15 years, and I'll compound that monthly. We actually already did that one, that first bullet point. And then what I want you to do is to do this second bullet point. Start with $4,000 and keep everything the same. And if you have time, you can do the third bullet point too, start with 8,000. But just go ahead and start with 4,000. Calculate how much you're going to have, and then also how much interest you gained. Okay, so that first bullet point's already done for us. Try the second one. And then if you have time, do the third one as well. I'll leave it up there. All right. So, you guys get this one? Okay. When I calculated it, I ended up with 9,816.37. Now I want you to notice something about this. Well, first off, we start with $4,000. So how much interest was gained? You take this number, subtract the 4,000. Interest that was gained was 5,816.37. Notice two things. The amount you had when you started with $4,000 is almost exactly double the amount you have starting at 2,000. Same thing with the interest gain. The interest gain is almost exactly double. It's slightly off because of rounding, okay? It's like a penny off because of rounding. You know, one I had to round up, one I had to round down, stuff like that. So because of rounding, it's like 1 penny off, but in reality, if you start with double the amount, you're going to end up with double the amount at the end, and your interest gain is going to be double. Now, you think that's only true for doubling? Of course not, right? If you triple the amount you started with, the amount you're going to have at the end is going to be triple. The amount you're going to have interest gain is going to be triple. If Warren Buffett, if I invest a certain amount of money and Warren Buffett invests 100 times more than me, and the stock goes up, he's going to end up with 100 times more than me. He's going to have gained 100 times more than me. Does that make sense? Now, on the other hand, if the stock goes down, he loses 100 times more than me, right? This works in the reverse too. If this were a rate that fell, he'd lose 100 times more than me. But if the stock price is going up, he's gaining 100 times more than me, as long as he invests 100 times more than me. Start out with. Everybody follow that? So there you go. So that's how starting amounts differ. And that should be kind of intuitive, right? In this formula that we have, the P kind of sits, as order of operation, the last thing you do is multiply by the P, okay? In order of operations, you simplify inside the parentheses, apply the exponent, and then do your multiplication. So the multiplication is kind of the last thing you do. You multiply that P. And so if you double the P, you're getting double the amount. If you times 100 the P, times 100 the amount. Does that make sense? So that comes right out of the formula. Now, next class period, we will start with changing the rate and the time. And those things work just slightly different in some interesting ways. So we'll start that next time. Does that work? All right. Other than that, make sure you're on top of things. You can do the first homework on the interest. Right now, you have all the tools you need to do the first homework on the interest. And that's due Friday at 5, along with that bonus homework for the taxes. Okay. All right, I will see you next time.